Same idea with all this. And now we're throwing in variables with exponents into the mix. Ultimately, the variables, I think you might assume they're going to make things harder. Dealing with the variables is actually easier than dealing with the constants or the coefficients. So the first thing we do is, all right, the fifth root of 32m to the 15th ends up being fifth root of 2m cubed raised to the power of 5. And then the 5s would essentially cancel, so you get 2m cubed. One way to think about it is when you think of the power to a power property, in order to get the new exponent on m, you divide the exponent on m by the index. All right, and then you get the 2 the same way that you would get the 2. It's the fifth root of 32. Here's one that has just exponents. Again, you're really just going to divide the 20 by 4 and divide the 8 by 4. Okay. You use an absolute value to indicate that the principal fourth root is non-negative. The reason why you have to do that is because when the index is even, you have to guarantee that what you're getting is the principal root, which is positive. Okay, so when you actually look at it, they're putting absolute value bars only around the x to the fifth. The reason for that is because y squared already is guaranteed to be even. So here's what I want you to consider. You need to use absolute value bars. They're used when two conditions are present. It's an even degree, because that's when you have to use the principal root. When it's an odd degree, the answer could be negative. All right. So cube root, fifth root, whatever, you don't even have to worry about this. Only when there's an even degree. And then the second factor that needs to be present is that the exponent, well, I guess I should say it the same way, an odd exponent. Because an expression with an odd exponent could be negative. So you need to put absolute value bars around it to guarantee that it's positive. If it's an even exponent, it's already positive. There's no way to make that negative. So that's why you don't need absolute value bars around the y squared. All right, let's look at the next example. I mean, not the example, the triad questions. Clear this out. So at this point, I want you to pause it and then come back and try. Well, try it and then come back. So for the first one here, cube root of negative 8 is negative 2. Cube root of a cubed is a. Cube root of b to the ninth is b cubed. You need no absolute value bars for this one because it was a cube root to start, so it was an odd root. For part B, the fourth root of 256 is positive 4. The fourth root of x to the 12th is x cubed. The fourth root of y to the 24th is y to the 8th. The x cubed needs the absolute value bars because it is an odd exponent that came from an even root. The positive 4 you already made positive, and the y to the 8th is an even exponent, so it's guaranteed to be positive. All right, let's look at example 5.